Section 11.2a is about adding and subtracting radical expressions. Radical expressions in which the radicands are alike can be added or subtracted in the same way that monomials are added or subtracted. So go back to the early chapters in the book. We learned that 3x plus 5x is 8x. You just collect like terms. Well, the same is true if you have 3 root 5s plus 5 root 5s. So you treat those root 5s as if they were x's. And so 3 of them plus 5 of them is 8 of them. Likewise, 12y minus 9y is 12 times 9 or 3, and that gives you 3y. In the same way, treat these square roots of 2's just like they were y's. So 12 root 2's minus 9 root 2's is 12 minus 9, or 3 root 2's. So these square roots not only have to be simplified, but you need to treat them as variables when you add and subtract. So here we're going to put some of those simplifying rules into practice. I have 3 root 11 plus 6 root 1 minus 2 root 11. Now you don't have to do this, but I'm just going to rewrite this as 3x plus 6y minus 2x. If that was the problem, you would know to put a box around these two like terms, make it 3x minus 2x or 1x, and then that would be plus 6y. You would know how to do that. Well, this is identical. It's the same thing. Here I have what's called like radicals. Not like terms, but like radicals. So 3 root 11 minus 2 root 11 is 1 root 11. You could put a 1 in front there, or you don't have to, but we know it's there. Plus 6 root 1. So your answer would be root 11 plus 6 root 1, and that's all you could do to simplify. Over here, 6 root 13 plus 7 root 13, they're both like terms. 6 plus 7 is 13, so you get 13 root 13. In this expression, I'm looking for like radicals, and those are radicals that are the same. The only like radicals I see are negative 4 root 2 plus 3 root 2. So we'll start by writing 9 root 17 first, and then negative 4 plus 3 is negative 1 root 2, or you could just write this as minus square root of 2, and then plus 5 root 7. I can't add or subtract any more of them because they're not like radicals. Now, as you look at this example, you may notice that these are not like radicals either. So you might just throw up your hands and say, I'm done, there's nothing I can do. But you must first try to simplify these radicals to see if you can make like radicals show up. What do I mean by that? Well, the square root of 12 has a perfect square in it. Root 4 times root 3. The square root of 4 is a 2, and 2 times 2 is 4. So this really becomes 4 root 3 plus 5 root 3. Now they're like radicals. 4 plus 5 is 9 root 3. So sometimes you may have to simplify a radical first to get it to be like the other one, and then you can put them together. Here I want to simplify this expression. I'll start by trying to simplify the radicals. Are there any perfect squares in 63? Yes. Root 9 times root 7. Square root of 9 is 3. So we'll have a 6 root 7 for that one. Are there any perfect squares in 28? Yes. 4 times 7. So root 4 times root 7. Root 4 is just a 2. So this gives me a 12 root 7. And the last one, root 45 is a 9 and a 5. So root 9 and root 5, square root of 9 is 3, and 8 times 3 is 24. So 24 root 5. So simplifying all three radicals by pulling out perfect squares. Now, do I see any like radicals? Yes, I do. 6 root 7 minus 12 root 7 is negative 6 root 7, and then plus 24 root 5. Last two examples, I think I'll let you pause the video, try them, and then I'll give you the answers quickly. So then we'll break up square root of 20 into root 4 and root 5. Root 4 is a 2, so negative 6 root 5. Square root of 7 doesn't simplify at all, so we just bring it down. And then root 45 is root 9 and root 5, which is a 3, so 2 times 3 is 6. Negative 6 plus 6 is 0. End up with negative square root of 7. This example, I can't break up the square root of 6. I can't break up the square root of 2. I can't break up the square root of 5. And I see no radicals that are alike. So I'm done.